residual on every data point. Yes, there is a chance, of course. So you have to reduce what? To make your equation perfect, what you have to do? You have to reduce this gap, right? The closer it is, the better it is. The closer it is, the better it is. The farther it is, the problematic it is. More the loss. The more it is, the more loss you have, right? So the principle of LSE is reduce the residual to minimum, and hence the theory says least square estimation. So a prediction based on minimized square, least square, but square of what? So this square is actually sum of square of residual. Okay, so this square is actually this. So let's call this residual by a unified term, beta x plus c plus epsilon. So this is going to be my residual. Why? Because had I considered a factor over here which would have brought my value down or brought my value up, let's say in above case, the value of epsilon was 2. So predicted by these two was 4 and plus epsilon was 2, so would have made the value of y as 6, which was exactly the value which was there in actuality, in reality. Yes, so we call this equation as y equals to beta x plus c plus epsilon. Okay, and this epsilon is nothing but residual. So sum of epsilon square has to be minimized. Okay, now how do you minimize? What is maxima and minima? So if you remember, d by dx of sum of epsilon square equals to 0 will give you maxima and minima. But d by d2x by dx square sum of epsilon, if positive, gives you minima. Okay, clear? So you will solve these two equations. You will not solve it. I mean, when you solve these two equations, you will come to know eventually that the equation will have minimum epsilon when the equation line passes or satisfies the centroid of data. Okay, the mean. Okay, so the equation, the line passes always through x bar, y bar to maintain this, to be minimum. Okay, so this is least square estimation. So you already know at least one data point through which your model line is passing through. Okay, clear till here? Anyone, any doubts till here? No one? Nothing? Okay. What happened today? People are not replying much. Boring session? Already tired of Saturday's party? I don't know. Yes, lovely. Too much info. Okay. But I try to make it as simple as possible so that if you're seeing it for the first time, you may not get disturbed by the idea. Not able to follow. Did not understand dy by dx. Don't worry, you don't have to understand actually. Dy by dx is differentiation. It is calculus. So if you don't have mathematics in your intermediates, you will not be able to understand much. Not able to follow. Which area have you lost it, Suman? Residual part. Residual is just extra, leftover. You prepare food. Maybe you're not able to eat the whole entire food. You leave some, right? But what do you do? From next time, I'll prepare food which is just sufficient for me or for the family, right? Or you have to find someone who eats voraciously in your family. Small change in x with respect to change in y is dy by dx. See, Dipankar has added in his name Dipankar Gyan. Good. Very good, Dipankar. No, not at all. See, this is just to understand what is going in the back end. You have to learn what R says. You don't have to learn what this is. Okay, you just have to understand what is going in the back end. Otherwise, you'll not feel interested about it. You'll be like, what is this going on? Something is happening. I'm writing some codes. So it doesn't make that interesting, right? To make it a little bit interesting and to help you see the picture behind the screen, okay, of your computer, this was done. Okay, now we'll just quickly go to the presentation and then we'll move ahead to R2. just to keep you in line with what is the difference in regression in SAS and R. No difference at all. Regression is regression. Simple, multiple, everything. Yes, lovely. Is this? Yes. Perfect, perfect, perfect. Okay. So, linear regression, and then this beta naught, beta 1, x is same as beta plus c plus epsilon. Okay. So x is the one which is having the beta for us, and beta naught is c for us. So you can choose anything to. It's just about notation. There is no fixed notation across the globe. Anyone can use any notation because it is mathematics. I don't know if you have heard that joke, but I'll just remind you of a joke. This point reminds me of a joke that there was a person sitting in the canteen eating rice without pulses, without dal. Okay, so he was just moving his spoon inside the bowl of intended for the pulses. Okay, but it was empty. So a person came and asked that why are you eating rice, or how are you able to eat rice without any curry or any pulses? So he said, I am a mathematics professor. I have assumed that there is something in this. So over here it is your choice. Whatever you want, you can choose, you can assume. There is no restriction at all. Beta naught, beta 1, alpha, beta, gamma, anything. You can create your own language in this. Okay, you want to make something, some signs here, some Chinese, Japanese signs. It's all acceptable. Okay. So this is what we were trying to understand, that there is a error. Okay, there's a slope and there's an intercept. Right? Now we'll do, obviously, this is the least square estimation method which I talked about. So you don't have to worry about it. We have already talked about it, and it is just to have an understanding of the back end. That is it. Okay. This is how it looks like in various cases. Now what is R square, that we'll see. Of course. What is R square? What is adjusted R square? What is standard error? Okay. What is dummy variable and what is interaction variable? Right? And thereafter we'll go to nonlinear, which is just to see the equations. Right? Cross validation is also a very easy thing. And then TCMF. Cool. So now if you see the equation which I had written earlier, what do you see? So I will rather take a snapshot of this. Just a minute, just give me 1 minute, I'll just get a bottle of water. Yes. So I'll just take a snapshot of this. What is the difference between residual and error? No difference, just the name. Then I'll cut this section and I'll paste it here. And somewhere here. Yes. Now it is easy to explain, right? Everything will be here itself. So if you see, can you see on this? Is it visible? No, let me change the screen, the color. Okay. So this is the way of doing linear modeling. You write LM and then you write Y. That is the dependent variable. Then over here you will write X, or if you want more, then you can write X1 plus X2 plus dot dot dot, whatever. And then you define the data set. Okay. So this is the basic way of writing a linear model. Now you will pass this to a model. Otherwise, if you straight away run this, you will only get the coefficients. You will not get other statistics. Okay. In this case, you first pass this to a model and then write summary of model. Then you get the entire summary about that particular analysis, regression model. So what are the analysis? Residual. What is the minimum residual? Minus 15. What is the first quarter? What is the median? Very small. The median of residual is very, very small. Third quartile. So most of the residuals lie between minus 7 to 5. And maximum of residual, that is delta of y, if you remember. Oh shit. Delta of y, the epsilon. So all the epsilon values are taken into account, all of them. Okay, and then this max and min is computed out of it, right, or taken out of it. Next is coefficients. So what are we trying to find overall? We are trying to find the value of y equals to beta x plus c. So what are we trying to find the value? Beta and c, right? This is what because we already have x and y. So x and y is there. This we have to find out. Got it? So you find out the value of coefficients and you find out the estimate of coefficient. Why is this an estimate? Because you have used least square estimation. So that is why you get the estimates. Now what is this intercept? This is the C, intercept. And what is this duration? This is the beta. Why? Because duration was actually your X, right? And this was your C. So X, the coefficient of X is this, and the coefficient of C is C itself, the intercept. Okay. So the coefficient of X is this duration. Please, all of you hear this very, very attentively. I'll not be able to repeat it again and again. Okay, so anyone who is not attentive will lose it seriously. Okay, so this duration is your X, right? Because you have written here that this is my X, this is my Y, this is my Y, this is my X. Yes. Okay, so the beta value will be calculated for duration. So this is your beta value, this is your C value. Now what is the standard error? Standard error is the standard deviation. Okay, it's nothing else than standard deviation of all the values. Okay, all the values that will come after you put these values. So all the values of output that will come is the standard error. Okay, so every value has every set of value has its own standard error. So we'll see in detail what is the standard error. Okay, P value is of course there to calculate your P value. Okay, there is no usage of t value here because you're not comparing two data sets here, or you're not comparing two columns here. You're just calculating t value to find out this PR. So PR is basically nothing but the p value. It's something like this, PR. Okay, probability PR, right? So this probability value, this is something really important. This PR should always be less than 0.05. If it is greater than 0.05, then it means that that particular variable is not significant for this model. So remove it. Okay, we'll see it further today, right? So this is greater than 0.05. Yes, so this is duration has got no significance for day. Okay, so duration and days are not related to each other. Got it? Now, standard residual standard error. Again, standard error is nothing but standard deviation. Okay, it is standard deviation of residual. So standard deviation of residual is 8.24. Great. And what is the degree of freedom? 5419. Why? Because there are total number of 5420 minus 1. The total number of observations are 5420 minus 1. Okay. Then multiple R square, which is also called as only R square, is this. Now what is R square we'll see. What is adjusted R square we'll also see. And then F statistics is not very much useful. But yes, P value over here is definitely useful. Okay. So this F statistics is basically, this P value is nothing but the P value you see here. Okay. Which says that my model is not good. This should also be less than 0.05. Okay. So I hope now you see a lot of yellow marks here and there and you understand it. Now, even if I had to form an equation, I was bound to form an equation, I would have formed it something like this. Day equal to minus 0.0007 times duration plus plus 16.1216272. Okay, and to predict if my duration is 0, then my day will be 16.12. Okay, if my duration is 1, then this will keep on decreasing. Why? Because this is in minus. So as my duration increases, day should decrease. Okay, so this will be my equation, even if I somehow decide to go ahead with this equation, although I will not, because of the p value and because of the r square value. So we'll understand what is p value. So we already understood what is p value yesterday. Okay, just the usage here is that if p value is greater than 0.05, then remove that variable, it is useless. Got it till here? Now we'll understand what is R square. So R square is nothing but square of R. Wow, beautiful. Got this? This is a remarkable line in my entire history. I've never said such a beautiful line. What is R square? R square is square of R. So R square, or rather how it is called as multiple R square, is actually coefficient of determination. And what does it do? It checks goodness of fit. Now what is goodness of fit? So goodness of fit means, let us say this is your equation, this is my data set. Okay, and this is my model line. So how many data points agree with my model. This. So you created a model and you said, no, I'll create a model which goes through here. I don't care about these data points. I just want my model to be like this. That's it. So that doesn't work, right? It has to satisfy most of the data points. So that is why R square value ranges between 0 to 1, both included. Okay. But R square value should always be greater than 0.8 to have goodness of fit. What does it mean? What does it mean that R square is equals to 0.8? What does it mean? It means 80% of my data points agree with or lie on my model line. So once you've created an equation, your sole purpose is to improve R square. Clear? Clear? Okay. Now, there is another term called adjusted R square. What is this? So when you are dealing with simple linear regression, then you check R square or multiple R square. But when you are dealing with multiple linear regression, then you check adjusted R square. Got it? So when it is y equals to beta 1 x plus c, then R square, and when it is y equals to beta 1 x x1, beta 2 x2, beta 3 x3 plus c, then it is adjusted R square. Clear? Okay, so this is more or less about what is R square. Delete this. Now what is standard error? So standard error is very well explained in the presentation itself. I don't need to write it. So standard error, if you see, is a measure of variability around the line of regression and can be used the same way as standard deviation. So how much is your data point around the model line deviated? Okay. So it is basically sum of square of error, sum of square of error or sum of square of residual, whatever you call it, divided by n minus k, that is total number of observation minus total number of rows, which is the degree of freedom. Okay, that is total degree of freedom. So that SSC divided by degree of freedom root under, okay, is your standard error. So it is basically how much is your data point across your model line deviated. Okay, and if it is 2, standard error is 2, within the range of plus minus 2, then it is 95% accuracy. If it is in the range of plus minus 3, then it is 99% standard confidence on the model. So this is your model. This is one type of variability. This is another type of variability. This is another type of variability. So this is on the plus side, this is on the minus side, and this is balanced. Okay, so it is just to decide that how much is your what is the variability across the line. Okay, what is the variability? How much is the data ranging in terms of moving up and down? Okay, so you check two things. One, obviously the R square value, and two, the standard error value. Okay, and the lower it is, it says that it is not good. Okay, lower is bad, like in this case. Standard error is very low of duration over here, very low. So you can say that duration is not nicely variable around the data. Okay, so the situation should be something like this. Sorry, situation would be something like this. This would be the situation rather than this. This is better, this is not better. Okay, so you basically understand it is what? Sum of square of error divided by n minus k. So forget n minus k, sum of square of error. If this is low, then this means that this is very high as compared to this. So sum of square of error is low and this is very high. Okay, so there are low errors, but it is only coagulated at one place. Across the variables, across the observation, it is not very nicely distributed. If this is high and this is also high, it is good. That across the variables, like across when you move around, this is what? N minus k is what? When you are moving around, right? So it should be equally nicely distributed rather than not coagulating at one place. So this is about all these. Now, what is dummy variable and what is interaction? Now, sometimes in equation, you will see that you have categorical variables. Okay, but categorical variables are like male and female. Now, in a equation, you can put only numbers. X or Y can only be numbers and not characters. So how do you then use them? If you think that yes, gender is something which is valuable, how do you use? So you assign a dummy value to these. Let's say male is given as 0 and female is given as 1. So conversion of character variables, categorical variables into number which is ordinal, it is ordered, right? 0 and 1. So it is called as dummy variable creation. And these zeros and ones are basically nothing but dummy variables. They are not actual variables. You're just dummying them. Right? And what is interaction? So now you think that these numbers individually are not putting any effect, But when they are multiplied with something, let us say age, then they are giving effect. So let's say ages are 20, 21, 22. So one is multiplied by 0 and the other is multiplied by 1. So this will age, the interaction variable will become 0 and 21 and 0 and 22 and so on and so forth, if you are multiplying like that. So the impact of gender and age can be seen together. So that is called as interaction variable. Okay, so we'll see all these, how do you use them inside linear modeling and everything. We'll see all of these, but after a quick short break. So I'm giving a break, a pre-break today. Not pre-break, I'm preponing the break today. Okay, because after this we'll straight away go to the equation forming and then we'll straight away go to non-linear things. They're related but not significant. Yes, correct, Amit. I'm not saying they're not related. They are related. Obviously, there's an interaction. There's a coefficient coming which is greater than 0. If the coefficient would have been 0, then they're not related. They're related, but they are not significant. So duration is not putting as much impact on day as any other variable would have been. Okay. So now I'm opening the, this is, for me it is 5:25. I'm opening the polling session. We'll have a quick 15 minutes break and we'll come back at 5:40 for me. Okay. So I'm opening the polling session and after this we'll start with multiple linear regression.